This video is going to teach you a little bit about tangent. So let point P, x comma y, be the point where the terminal ray intersects the unit circle after rotation theta degrees as shown in the diagram below. So here's the point, x comma y, we're going to label that P, and here's theta. Now remember, we're on the unit circle, so they've labeled the radius as 1. So this is 1. Now, anytime we draw an angle on the unit circle, we can make a triangle. So here's my triangle. I've outlined it in blue. Now, that triangle I've labeled, or the picture has labeled, the x-coordinate and the y-coordinate based on this point on the unit circle. So the base of this triangle down here is x, and the height of this triangle over here is y. Part A, find sine theta and cosine theta in terms of x and y. So, SOHCAHTOA, sine theta is equal to opposite over hypotenuse. So here's opposite, and here's the hypotenuse, and here's the adjacent, because remember I'm talking about this angle there. So opposite is y, hypotenuse is 1. So that means that sine theta is equal to y. And now if I'm going to do cosine theta is equal to adjacent over hypotenuse. So the adjacent is x, and the hypotenuse is 1. So that means that cosine theta is equal to x. And these are two things you should already know, and there are previous videos that talk about these as well. Now they want us to find tan theta. So tangent theta is equal to opposite over adjacent. So if I go back to my diagram, my opposite is y, and my adjacent is x. So tan theta is equal to y over x. Part C, given how we define sine and cosine, how can we define the tangent function in terms of sine and cosine? Well, in part B, we said that tangent theta was equal to y over x. In part A, we said that sine theta was equal to y and cosine theta was equal to x. So that means by substitution, tangent theta is equal to sine theta over cosine theta. So that's how you're going to remember tangent theta, y over x or sine over cosine. So in terms of sine and cosine, tangent is defined as, we just said, tan theta equals sine theta over cosine theta. For cosine theta does not equal 0. Why do we need to specify that cosine theta cannot equal 0? Well, cosine theta is in the denominator. And we know from previous units, you can't divide by 0. So if I can't divide by 0, that means that my denominator can't be 0. So therefore, I have to specify that cosine is not allowed to be 0. In fact, when cosine theta is equal to 0, that means that it's not cosine. That means that tangent is undefined, because I would be dividing by 0. So looking at the unit circle, identify 5 values of theta that will cause tangent theta to be undefined. So tangent theta is undefined when cosine theta equals 0. And now remember, cosine theta is x. So when x equals 0, tangent is undefined. So remember, on our unit circle, x comma y. So that means it's going to be undefined here, and it's going to be undefined here. So I have 90 degrees, and I have 270 degrees. Now they wanted me to identify 5 values of theta. So we have, remember, coterminal angles. So that means I can continue adding and subtracting. So let's do subtracting first. My positive angles went counterclockwise. That's why I have 0, 90, 180, 270, and 360. My negative angles can go clockwise. So 0, negative 90, negative 180, negative 270, negative 360. So I've now added 2 more. I have negative 90 degrees and I have negative 270 degrees. So we got to get 1 more because they wanted 5. So if I go coterminal in the other direction, I'm going to keep adding. So that means that I went 0, 90, 180, 270, 360. So now from 360, I have to add another 90 degrees to get up to that quadrantal angle in between the first and second quadrant. So if you need to, 360 plus 90. That will give me 450. Because up here is 450 degrees. 450 degrees is coterminal with with 90. I can check that by subtracting 360. And I get 90. That's how I know that they are coterminal angles. And you can keep going. But they wanted 5, so here are 5 angles where tangent theta is undefined.